All right, so in this video, I wanted to kind of review electron configurations. All right, so electron configurations, all in a nutshell, it's just basically how the electrons configure themselves around the nucleus. All right, and so in time past, we kind of looked at the Bohr's model of the atom, and the Bohr's model of the atom is kind of like the solar system depiction of the atom, and we have experimentally figured out that that depiction of the atom is completely incorrect, but we teach it for various reasons, kind of giving you an idea where the protons and neutrons are located, where the electrons are kind of located. But now we kind of moved on into a more modern atomic theory where we have this whole idea of electron configurations. Now, with electron configurations, all right, electrons are basically configured in sublevels, energy levels, orbitals, and so on and so forth. All right, and so like the first thing we want to talk about is that electrons are in energy levels, and the energy levels are just basically like the main areas that you can find these electrons. So like for example, the energy levels are basically, we notate them as N, and they go from 1 to basically infinity. It can be infinity, but energy level number 1 is the energy that's close. It's the energy level that's closest to the nucleus, and then as you move on to 2, 3, 4, 5, 6, 7, the energy level is further and further away from the nucleus itself. Okay, now off Bohr's principle basically states that electrons, they like to be in the lowest energy level as possible. So, for example, if you have a nucleus and you're putting in your first electron, and the first electron is going to go into energy level 1. I mean, that's where it's going to go. All right, and as you fill them up, then the electrons start filling energy level 2, then start filling energy level 3, 4, 5, 6, and 7, and so on and so forth. Okay, now the next thing, after they go to the energy levels, you have sublevels. So now there's 4 basic sublevels that electrons tend to have, or atoms tend to have. I mean, there's more sublevels, but all the electrons in ground state fit in these 4 sublevels. Okay, and so the 4 sublevels are, you got the S block, then you got the P block, the D block, and the F. Well, S, P, D, F. Okay. So those are your 4 sub-levels. Now, depending on the sub-level, depends on how many electrons could fit in that sub-level, okay? But before we talk about that, so kind of taking it back a little bit, you have your energy levels, all right? So once again, your energy levels, like 1, 2, 3, 4, 5, 6, 7. So the periodic table typically has 7 energy levels. Within the energy levels, all right, they are subdivided into sublevels. So once again, here are your sublevel S, P, D, and F. Now within sublevels, we have what we call orbitals. So you got your orbitals, okay? Depending on which sublevel, depends on how many orbitals you have. So within the S sublevel, there's only 1 orbital. Within the P sublevel, you have 3 orbitals. Within the D sublevel, you have 5 orbitals. And then within the F sublevel, you have 7 orbitals. Okay? And so that's basically that. So you guys all make sure you memorize that. Make sure you know that. As I said, this is just mostly review for many of you guys. Okay? So that's that. Okay? Now, in an orbital, all right, in all cases, so I'm going to kind of screw this up a little bit. So within an orbital, all right, it could have the maximum number of 2 electrons. Okay, so within the orbital, you can actually put in 2 electrons. So what does that mean? All right, when you kind of look at the grand scheme of things. All right, so if S has it has 1 orbital. So S, so here are your sublevels. Okay, here are your orbitals, and this is going to be the maximum number of electrons. Okay, so if S only has one orbital, the maximum number of electrons within the S sublevel is 2. If P could only have 3 orbitals, the maximum number is 6. D, 5 orbitals, maximum number is 10. And then F, 7 sublevels, and the maximum number will be 14. Okay? Now, depending on the energy level, depends on what sublevels can exist. Okay? So, like, for example, all right, for all energy levels, all right, so you can kind of look at this periodic table here that I'm showing you, and I'm just kind of highlight it so that you can see exactly what I'm talking about. All right, so if you noticed here, S sublevel can exist in all energy levels. All right, so you see S starts out up here, and it goes through 2, 3, 4, 5, 6, 7. So all the energy levels, there's also S over here, all the energy levels contain at least an S sublevel. Okay, for sublevel P, if first are introduced in the second energy level. Let me find out highlight this a little bit more. All right, second energy level, and then goes on from there. Okay, so S starts in the first, P starts in the second. Okay, D actually starts in the third. All right, so starting the third sublevel, the D sublevel, they're starting from the third energy level. Sorry, the D sublevel is introduced. Okay, and then last, starting from the fourth sublevel, the F, starting from the fourth energy level, the F sublevel is introduced. Kind of mixing up my energy level sublevels, but hopefully you understand that. So the first energy level, starting from the first energy level, the S is introduced. So you will never have a D sublevel in the first energy level, F sublevel in the first energy level, nor a P. Okay, starting from the second energy level, you will start seeing P. Now in the second energy level, you could have S as well. So like if you're looking at this periodic table, hopefully you can see that. All right, that in the second energy level, you have S, and then you can get into contact with P. Starting from the third, you have S, you also have P, and depending if you get there, you have D as well. And then in the fourth energy level, you have S, P, D, and then F. Okay, and as I said, there are more energy levels that go to energy level. Sublevels. You have sublevel G, H, I, J, whatever the case may be. But usually electrons only reach to those sublevels if they are excited, if they're given energy and they're jumping from one energy level to the next. But when they're all at ground state, or at least all the 118 that we know at this moment, when they're in ground state, they only occupy the first 4 sublevels. Okay. All right. So the next thing that we're going to do, we're going to actually just kind of quickly practice how to write electrons configurations. Okay, so I'm just going to give you guys a couple examples. Kind of move this around. All right, so I'll give you guys a couple examples so that way we can just kind of practice. All right, so we're just going to do a couple examples of electron configurations, so that way that we can just remind ourselves how this works. Okay, so like for example, let's look at, let's write the electron configurations for beryllium. So beryllium sits right here, okay? So when you're writing electron configurations for beryllium, okay, we just have to keep in mind that beryllium in this case has 4 electrons. So you can kind of count this out. 1, 2, 3, 4. So when we write the electron configurations, we have to make sure that we show that there's 4 electrons. So the first thing you want to do, you always want to start from the top left, as much like you reading a book. When you have words in the book, you always start on the top left and you read it all the way through the right. Once you're done with the right, then you move on to the next line. So writing electron configurations, it's the same exact process. Okay, so you start off with the top left. So here we got 1s, so that's the first thing I'm going to write, 1s. How many electrons in the 1s? Well, you got 1, 2. All right, so I'll put 2 as a superscript here. Then I'll move on to the next line. So my next line I have 2s. So I'm going to write 2s. How many electrons do you have here? Well, 1, 2. Since beryllium is what we're trying to get to, we're just going to count that element 2. And there you have it. You have the electron configuration of beryllium. Okay, let's look at another one, one that's a little bit harder. So we have silicon sits here. Okay, so you write the electron configuration for silicon. Once again, you start from the top left, all right, and you work your way all the way through until you reach beryllium. So you have 1s. How many? 1, 2. Then you have 2s right here. How many? 1, 2. Then after 2s, you have 2p because you're reading it to the right. So 2p, how many do you have? 1, 2, 3, 4, 5, 6. Then we have 3s. How many do we have? 1, 2. Then we have 3p. And how many do we have? 1, 2. And so that's basically how you find the electron configuration for silicon. All right, let's do another example. All right, so let's go ahead and let's look at another one. And so the one I'm going to choose this time around is, let's try yttrium. And so yttrium sits here. All right, I'm going to try to draw black so you can really see what I'm talking about. So that's yttrium. And right here. So the yttrium's electron configuration, we see that's 39 electrons. Okay. And so once again, you just kind of start from the very top and just kind of run through it, going reading to the right. After you're done with it, then you move on to the next line until you reach the element that you're looking for. So here we got 1s. How many have 1s? Well, you have 1. Read all the way to the right. 2. So I have 2. My next line, 2s. How many do I have? 1, 2. Move on to the right. What do I have next? 2p. How many do I have? 1, 2, 3, 4, 5, 6. Move on to the next, 3s. How many electrons do I have? 1, 2. Read all the way to the right. Then I have 3p. Then you read 1, 2, 3, 4, 5, 6. Then next is 4s. How many do I have? 1, 2. Then, interesting enough, we're going to 3D. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I have 4P. Then it's 1, 2, 3, 4, 5, 6. Okay. Then your next is 5S. Then it's 1, 2. And after that, then you have 4D. Since the yttrium is right here on the 4D, the first one, so it's 4D1. All right, so that's the electron configuration for this. Now, there's a short way form of it, and we call it noble gas configurations. And so basically what you're going to do is that whatever element of question that you're talking about, you just choose the noble gas that comes before it, and then you write out the rest. So I'm going to quickly show you an example here with yttrium. Okay, so for yttrium, you want to find the noble gas that comes right before it. So since yttrium is here, you look for the noble gas that comes right before it, which is this element here. And this element, if you look on the periodic table, it is krypton. So what I will write for the electron configuration for yttrium, in brackets, I will write krypton. So what does this mean? Well, when you write in krypton, you're writing basically a configuration of up to the greatest P6. Okay, so if you're looking at this, right, at this configuration here, the greatest P6 is here. All right, and so all this is understood by putting krypton in bracket. Okay, and then what you have left is what you write after it. So it's 5s2, 4d1. Or other words, is that when you write the electric configuration, or when you write the noble gas inside the bracket, you could basically start on the same line that your element question is on. So we covered the first 4 rows. Now we're going to start on the fifth one because the yttrium is on the fifth one. And all we have to do is 5s2 for D1. All right, so we could just do another example here. Let's say I wanted to write the electron configuration for phosphorus, okay? So phosphorus is here, and I want to write simply the noble gas configuration. Well, you have to figure out what's the noble gas that comes right before phosphorus, not after, but before. And so the noble gas that comes before phosphorus is neon. Neon's right here, okay? So what I will do, so here's phosphorus. I write in parentheses neon. So this covers essentially, really, this covers, I'm going to highlight this whole top section, okay? This whole top section is covered by the brackets of neon. So all you really have to do is start in the same row that neon is in, all right? So you start here. So what not neon, but phosphorus in. So we'll start right here. So phosphorus, we have 3s1, 2. And then we have 3p1, 2, 3. And that's the noble gas configuration for phosphorus. So hopefully this is a good and helpful review.